CloudDB, shaping your new normal.
Welcome everyone to the 2022 APEC OCI Days by Apaco UC. This is our first year having a dedicated OCI event. It's an honor and privilege to run this event with the support of 15 Oracle user groups and Java user groups in the region. Please remember to register to as many sessions as you can. This way you will be able to access all the replays until June 15, 2022. I would like to say thanks to our Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle ACE Community, the DevRel team, and your main sponsors, Oracle Corporation and CloudDB. Now for today's session, Terraform on Oracle Cloud Infrastructure, a primer for database administrators by Sean Scott. If you have any questions to Sean, please feel free to use the chat window in the right lower corner of your screen, and Sean will be answering all your questions by the end of the session. If you have any technical issues, also please feel free to use the same chat window, and I will try to help you the best I can. Now, without any further ado, I want to leave you with this amazing session by Sean Scott. Sean, the room is yours.
Thanks so much. I appreciate the introduction. Thank you everyone for being here today or tonight, wherever you may be. It's getting on evening here. I'm in the Western US. So we're going to talk about Terraform on Oracle Cloud. And this is an introductory, not a deep dive session. This is a get your feet wet, get slightly under the water, but not too far session for folks that may not be familiar with Terraform already. Really briefly about me, I've been working with Oracle Technologies since around 1995. I'm an Oracle ACE, Oracle Certified Professional, Cloud Architect and DBA, and I've presented at Open World and Collaborate and regional user groups for a number of years. I started out as an application developer and kind of fell backwards into being a DBA. Then ended up running a consultancy of my own for a number of years and spent a good chunk of my career in operations and database reliability engineering. Work a lot now with Rack and DataGuard, partitioning, sharding, engineered systems. I do a lot of work with diagnostic tools like Autonomous Health Framework and ADR, RDA, and so forth. But a lot of what I do really centers around what I really love doing, actually, centers around automation, things like Docker, Ansible, Python, Perl scripting, Bash scripting, and Terraform. And so today I'm here to talk to you about Terraform. Oops, we went one slide too far. There we go. So Terraform, originally it started out as a verb. It was brought to use in the 1940s, roughly, we think, and it refers to a science fiction term. I read a lot of science fiction when I was a kid, and I remember a number of books that talked about terraforming, and it's this idea of taking an alien planet and making it habitable for human life. And more recently, we've seen terraforming in modern science fiction. It's part of the plot line from the Superman movie, Man of Steel. Villains come and they're going to terraform Earth to make it more like Krypton for them. But we don't have to go to science fiction to find examples of terraforming, real life terraforming. It doesn't require any kind of alien technology, not even modern technology. We as humans have been terraforming our planet for thousands of years. Everything from rice fields, vineyards, to entire cities like Venice, greenhouses, and even aquariums. So if you have ever owned a fish or reptile, or if you've kept an herb garden on your windowsill, if you've raised tomatoes or orchids or tulips or any kind of plant outside of their native habitat, outside of their normal climate, you have done terraforming, which means we're probably all bringing some amount of experience, whether you realize it or not, to today's subject of Terraform. Terraform, the noun this time. Terraform is an infrastructure as code tool from HashiCorp. HashiCorp, if you're not familiar with them, they're the same folks that bring us Vagrant and Packer. And Terraform is a tool that lets us define infrastructure through configuration files. And those configuration files tell Terraform what we want the end result to look like. And then Terraform goes out and it does all the work for us. It builds the infrastructure to match our requirements, to match our requests. But Terraform goes beyond just simply provisioning infrastructure. We could do that with a script, a bash script, or a Perl script, or a Python script if you wanted. The configurations we create with Terraform, we're declaring an end result that we want. And Terraform takes care of those details for us. But Terraform will also look at that configuration, that desired end result, and let us revert an environment that is maybe strayed off the path back to that known controlled state, or we can update that configuration and apply changes to it that we can then send out to our infrastructure to extend an existing system, to change it, to modify it over time. And of course, all these files, these are all text files that we're talking about, so we can put them into a Git repository and use version control and things like that to manage our configurations and keep really good track of them, so that we've got a good control over our environments. So we can use Terraform to build low-level components, things like storage and compute and network resources. But we can also use it to build things like complex, high-level things like DNS, to manage security in an environment, to pass configuration, to run scripts. And we can even build a database with Terraform, which we're going to do a little bit later. So one of the things that you should know about Terraform is it's a declarative and not an imperative language. And if you're not familiar with the differences between the two, I think to really appreciate how great declarative syntax is, I want to look first at what the imperative steps are of putting together something like a fish tank. So an imperative set of instructions is very, very specific. It tells you step by step everything you need to do. So if we wanted to put together a fish tank, well, we need a tank, right? But we need to tell imperatively exactly what size tank, what the dimensions are, how big it is, the brand of tank. And then we're going to need to have a pump and maybe a heater to put all of that together so that we've got our base environment. We've got to have the right pump to match our tank. We've got to have the right heater that's going to keep the water temperature to the volume of water that we have set correctly. And we're going to need some instructions that tell us how to put all this together. And then we need to know how much water to add and how much salt so we've got the right salinity, set the temperature so our fish are going to be happy and everything. But the problem with this imperative process is the steps for putting together, let's say, a 10-liter tank are going to be really different than if we want a 3-liter tank or a 20-liter tank instead. So not only do we need a different tank, we'll need to match a heater and a pump to that tank. And not only to fit the tank, but to support the volume of water. And would it change if I want a tall, skinny 20-liter tank versus a wide 20-liter tank? You know, do I have to worry about the depth of the tank and make everything matched? Am I going to need different stuff? I don't know. I'm not a fish aquarium expert. And then when it comes to adding the salt, are the ratios, I mean, is the salt to water ratio, is that fixed, or am I going to need to adjust salinity? This is getting really complicated. But with a declarative process, I say, I want a fish tank. It should be about this big, and I want you to figure out how to do it. And if you think about it, that's how most things in the world outside of IT work. When I go and let's say I want to buy a car, I don't go to the dealership and tell them how to assemble the engine and upholster the seats and all that. I just say, I want a car. I leave the car building up to the people who are experts at cars. And from our fish tank example, well, I can do the same. I just declare I want a fish tank and I tell it I want it to be this big. And I trust my expert to solve all the problems like what pump and heater and so forth, how much water and salt, all that. I don't want to have to worry about that. I just want a fish tank. So I rely on my expert to put all of that together. And that expert, not only does he know whether or not the fish tank already exists, so if my heater fails and I say, my heater failed, he's not going to go out and build me a brand new fish tank from scratch. All he's going to do is replace the broken part based on the configuration. And probably the most important thing about Terraform, the most useful thing about Terraform, is it scales by definition. I'm giving it the scale that I want right in the instructions. So it's going to figure everything out from there. So whether I need a fish tank to sit on my bookcase, or I am a national aquarium that wants a 1,000,000-liter shark exhibit, the expert is going to provision and figure everything out for me accordingly. So that expert that I'm talking about, the person that understands the fish tank, we call that in Terraform a provider. And a provider has a catalog of all the unique features and capabilities of a particular environment. It knows its rules, and it understands how to put everything together to build what we've defined in that configuration. Now, providers are target specific. A provider for OCI isn't going to work on AWS and vice versa, because there are different architectures, different product offerings. There's no Aurora in OCI and no Exadata in AWS. So our provider recognizes the dependencies in these configurations and acts accordingly. And there's no need for us to define things in any particular order when we build this configuration. Terraform is going to read our configuration, and it knows, because it's the expert, it knows how to determine the correct sequence for provisioning every component in our system. So Terraform has a lot of advantages. It removes a large quantity of the complexity of building infrastructure by abstracting that into the provider for us. So with a script or any kind of hand-curated system, we need to anticipate and define every possible condition. In Terraform, if we want something, we can get it without having to worry about the implementation details. So I mentioned before that Terraform has awareness of the current state of the system, and that leads to a handful of really neat capabilities, advantages. The first is idempotency. If you're not familiar with that, an idempotent system, I can run that script repeatedly, and I'm never going to damage anything because the result is always going to be the same. So going back to my fish tank, if my heater breaks and I run my create a fish tank Terraform provisioner, it's going to go out and it's just going to replace the heater because it recognizes that the heater is not in the desired state of a working heater. Whereas if I don't have an aquarium at all, well, it's going to build the whole aquarium for me. I always end up with a working environment. And that means that Terraform has to have some understanding of the environment. So it tracks my environment for me, and it's going to recognize the differences between the declared state, what I want, and the current state, and identify if things are amiss and report for me any configuration drift. So I can see, yes, this environment is not working as I want it to. So I want to set it back to the right, to its rightful position or its rightful state. And of course, that means with idempotency and this awareness of our environment, we get very repeatable outcomes. So I can apply a Terraform configuration not only to an existing environment, but I can take it and I can run it somewhere else in an entirely different environment. And it's going to produce functionally identical systems. The only difference would be any variables that we decide to include and set differently. That would be the only thing that's going to end up differently. And finally, we can, of course, update our configurations as necessary. We can reapply them to the environment and manage our infrastructure through its entire life cycle, from that introductory phase all the way through maturity. So getting Terraform, really straightforward. You just go to www.terraform.io/downloads. And that page, I captured the screenshot a little bit earlier today, has instructions for probably every operating system that you will need. I'm not going to go through the details of how to install Terraform or anything like that. You can do it from the command line. You can do it as an installer on systems like Mac and Windows. You pull the package on Red Hat. You can brew it on OS 10 and so on and so forth. I'll leave that. You're all, I'm sure, very qualified, very smart folks who can download and install software on your own. But what I want to get into is how we're going to set up our provider for OCI. So we need to get some information from our OCI environment. And the first thing we need to do is go out and get we need to first create a public key on our OCI environment. So we'll go to our hamburger menu and click on identity and security, and then select users. We're going to choose the user that we want to be able to run Terraform, and then select the API keys down in the resource menu. It's going to be over on the left-hand side down near the bottom. I'm going to get a screenshot here. Once you've selected the API keys option, you'll get down on the lower portion of your screen, you'll have an option to add an API key. So click on that button. And then you'll get a dialog that'll pop up. Follow the instructions in that dialog, whether you want to paste a key, whether you want to choose an existing key, generate an API key pair for you. Oracle Cloud will do that for you. Go ahead and perform that work. And then when you click add, you're going to be taken back to your original user screen, and you'll see a fingerprint for your newly created key. So we need to copy paste that fingerprint off. We're going to need that in just a little bit. Then we're going to gather some additional tenancy information. Probably the easiest way to get all of this is you go up on your OCI console, and in the upper right-hand corner, there's a little picture, a little icon of a person. That's your profile icon. Click on that and select tenancy from the menu, and that'll bring up your tenancy information. And the next bit of information we need is the tenancy OSID. There's a handy little link that you can use on the tenancy information screen that will copy that OSID. So we'll copy that and save it off. And we're going to do something really similar for the user OSID. This is the user who is going to run Terraform. You click on that profile, and this time click user settings. And then again, just use that copy link to copy the user OSID off, and we'll save that someplace. And again, we'll click on that profile at the top right. Select not the profile button. I mistyped that. Select the region dropdown. So you see where I have US West Phoenix on mine. There's a little downward arrow. Click on that little downward arrow, and that's going to take you to the region dropdown. From there, you get the region identifier, and mine is US-Phoenix-1. And then the last bit of information we need is the private key path. That's the path that we use to create our keys during that API key creation step. And then the region. Oh, I already got the region. Beg your pardon. So with all that information, now we have everything that we need to start a Terraform project. There are some really great things about Terraform. First off, there's no naming convention for anything. Terraform files have a .tf suffix or file ID. So as long as your files in a directory are named something.tf, Terraform is going to understand that those are Terraform files, and it will read them for you. So you can call them anything you want, doesn't matter. And you don't have to worry about indentation or spaces versus tabs. Even though spaces are superior to tabs in every single case, you can put tabs in if you want. Terraform, when it runs, is going to read all of the .tf files in your directory, going to collect all the information it needs and build a manifest from that. So for this project, we're going to build an Oracle Autonomous Database on OCI Cloud. And I'm going to create 5 files for this project. The first is called providers.tf, and that's where we're going to tell Terraform information about the provider that we want to use. And then we have a file called variables.tf. That's where we're going to declare and define our variables. And we can also set defaults and values in this variables file if we wanted, but we're not going to. I'm going to show you why in just a few moments. And the third file that I'm going to create here is called terraform.tf vars. That tf vars suffix tells Terraform this is a file that has Terraform variables in it. And that's the file we're going to use to pass some values over to Terraform so it knows what to do with some of the things like passwords and maybe a database name and so forth. And then later, we're going to create two more files. The first is called main.tf. And I just called this main.tf. That's kind of a Terraform. It's not a standard. It's not a best practice. It's just something that a lot of people do. So if you find a main.tf, that's probably the main Terraform file in a configuration or in a project. And that's where we're going to create where we're going to declare the configuration for our autonomous database. And the last file is going to be a file called outputs.tf. That's where we're going to capture some information from Terraform and display it out to the user. So the first one here is this providers.tf file. And you can see here, a lot of these look really familiar. This tenancy OSID and region, user OSID fingerprint. These are all values that we collected a little bit earlier. Remember that when we were looking at our OCI environment? And over on the right-hand side, you see that I'm setting them equal to things called var dot and then some value there or some variable. That var says this is a variable, and so I'm telling it this is the variable called tenancy OSID, the variable called region, variable called user OSID, and so forth. You can kind of think of this providers.tf file almost as credential definitions. Now, I could put the actual values into this file if I wanted, but instead I'm using variables. I'm going to put the variables somewhere else. Now, this is our whole providers file. This is everything that we need to tell Terraform we're going to work on OCI. That's it. That's the whole thing right there. The next thing I have is this variables.tf file. Now, again, I could, if I wanted, have hard-coded values directly into the providers.tf file, or I could hard-code them in here. But if I did that, it would mean that my code wasn't very portable. So if I had that providers file and I had my values hard-coded into it, well, I couldn't use that providers file on a different tenancy or with a different user or a different key. So now I have this variables file. This variables file is where I declare the variable. It's where I tell Terraform, I am going to use a variable called tenancy OSID, region, user OSID, and so forth. And I could hard code the values for my tenancy and region in here too, but that would mean that my variables file wouldn't be portable. So by putting those hard-coded, those changing values somewhere else, I can reuse this variables.tf and my providers.tf on multiple different projects that I want. That's why I want to keep them separate. And I keep them separate by using this terraform.tf vars file. This is where I'm going to put the actual values for all these variables that Terraform is going to use. So this is where I'm going to put in the values from my tenancy that I collected earlier. This tf vars file, I can use this now on any Terraform project that I want to run in this tenancy for this user. So the terraform.tf vars is reusable, just like the providers and the variables files are going to be reusable because I've separated everything out. It makes my code a lot more portable this way. So now that I have these files created, well, I can go in and I can test the configuration. This is everything that I need to declare to Terraform that I have a project that I want to run. So it's a bare bones configuration. There's not a lot to it, but I've given it credentials and information about the provider so I can initialize my project and then I can plan it and apply it. And these are the two steps, plan and apply, that we run in Terraform. So because I've just created this brand new project, the first thing that I need to do is Terraform init. That's going to create state files and housekeeping information that Terraform needs to manage my project. So I run this Terraform init, and it's going to go through this process and give me some information. It'll come back and it'll say, hey, you're good to go. Everything you need to run a project here, everything is kosher. We're good. I've got all the information that I need to work with. So the next thing we do is we run Terraform init. And this is, I'm sorry, sorry, did I have this? Oh, sorry, I was looking at the wrong thing on my display here. So this is Terraform init, where it goes through the process and it says everything is good. You can see that I've got my project is built and everything. I've got that slide in there twice. That's what confused me. And then the next thing I do is I run this Terraform plan. I beg your pardon for my confusion. I have too many screens running on my desktop here. So the next thing after I've initialized, I run Terraform plan. Terraform plan is the way of saying, hey, Terraform, I would like to know that you are able to understand my configuration and that you can build all this stuff out. And maybe you can give me some information about what you're going to do. In this case, I don't have a whole lot. So Terraform doesn't have much to say back to me. It just says, hey, no changes. Your infrastructure matches the configuration. Well, it matches because there's nothing out there. And so it says, hey, we're good. We're good with Terraform plan. And the next thing I can do is I can run this Terraform apply. Terraform apply is going to go out and it's going to say, well, there's nothing for me to do. So I'm just telling you that everything was successful. So this is great. Terraform is up and running. It took us a few minutes to do this. Now we can go and we can start the actual process of building an autonomous database resource. So we need to create a configuration for that. And that sounds scary, doesn't it? So this is where I'm going to use that main.tf, where I'm going to put my configuration information in for my autonomous database. And I'm going to add some variables that I need for my autonomous database to my variables.tf. And then I'm going to add values to my terraform.tf vars. And then I will go into my output.tf file and generate some or capture some output from Terraform so that I can display it back to the user. So creating an autonomous database sounds like a really scary thing, but this is it. This is everything you need to create an autonomous database. We're just telling it, hey, you know what? We need to create an autonomous database, and we're telling it here a resource. We're creating a resource, and the type of resource is OCI underscore database underscore autonomous underscore database. And then we're giving it a name. We're saying this OCI autonomous database, I'm going to call it autonomous DB. Now, this is not the database name. Like if you were to log into the database and query the name of the database, this is not that. This is the name that we're giving Terraform so that Terraform can track the resource. So you don't want to confuse the two. So we say, we want a resource, we want an autonomous database resource, and we need to give Terraform some information. First is the compartment ID. Well, for the compartment ID, we're just going to use the tenancy OCID right now. This is going to create our database in the root compartment. You can supply a compartment ID separately if you would like, if you want to work on this and make it a little bit more custom and perhaps a little more proper for OCI security and so on and so forth. And then I'm going to give some information like the database name and the display name, the database version, the type of workload, and then some scale information like CPU count and the storage size, whether or not it's a free tier database, what kind of licensing I'm providing, and then the admin password. And that's it. That's everything I need to create an autonomous database. So this is the beauty of this declarative syntax is I just say, hey, I want some stuff and this is what I want it to look like. And Terraform takes care of the rest. So that's the whole configuration of an autonomous database right there. Next thing I need to do though is I need to go in, I have some brand new variables that I created as part of that configuration. So I need to declare those variables in my variables file. These first three, the database name, the display name, and the admin password, well, these are values that are probably going to change for every database that I create. So all I'm going to do is just define the type of variable. And these are all strings. And you can have strings, integer, Boolean, all sorts of different types of variables defined here. We're keeping it simple with strings and numbers. The next few variables, these are things that I might want to set defaults for. For example, the database version. Maybe I know that I'm always going to create a 21C database. So I can set the default value here in addition to telling it what type the variable is. And the same thing for my database workload. Maybe I want to create a whole bunch of OLTP databases or data warehouses, whatever. I can go ahead and I can set that default. I don't have to worry about telling Terraform elsewhere that I want to have an OLTP database or a 21C database. And the same thing goes for my CPU core count and my data storage size in terabytes. Actually, that type should be number, not string, my typo, but it works nonetheless. And then the same thing for whether or not it's a free tier or a license included. I just go ahead and provide this information. I can provide some defaults in my variables file. Now I'm going to go and I'm going to pass actual values that I want into that TF vars file that I created before. And this is where we have that hard-coded information. We're keeping that hard-coded stuff separate from our reusable components. And so I'm setting the database name and the display name, and I'm setting my admin password. But I could also, if I wanted to, in this file, if I wanted to override any of those default values for maybe the database version, I could set that and assign that variable here. And Terraform will go through, it's going to read this file, and it'll say, well, I've got the default of a CPU core count of 1, but the user has said, I want to have 2 instead. And so it'll override that value and pass that. And then the very last thing that I'm going to create here, this is just for convenience. It's called outputs.tf. And from here, I'm going to capture information that Terraform sends back when it's done so that I can see something about my resource creation, about my Terraform job that run. And the first of these is I'm saying, I'm creating this thing called a DB name, this value called DB name. And the value that I'm capturing is an OCI database, autonomous database, which is the resource, if you remember from our main.tf file. .autonomous DB, that's the resource name that we assigned to the resource. .display name, and display name is a known quantity that Terraform shares for this type of resource. And then the same thing for this DB state. We'll get the state of the database. And so when our Terraform job is complete, it'll come back and it'll say, hey, you asked for some information. I'm going to show you that in this outputs. I don't have to do anything special with outputs. I don't have to do anything to make that appear, nothing like that. It's going to do all of this for me completely automatically. So from here, I've got my configuration for my database. I can go out, I can run Terraform plan, I can run Terraform apply. I don't need to init like I did before because I've already initialized my project. All I need to do is plan and apply it. So this is what Terraform plan will look like when I first run it. It'll go through, show me some information, then it's going to finish up. This is the very last section of a rather lengthy output. And you notice here that I've got some outputs. Those are the outputs that I requested in that outputs.tf file. The first one is the DB name. So it says, hey, I know the DB name because you defined it to me, but this next part, known after apply. Well, of course, the state, it doesn't know because it hasn't created the database yet. And it doesn't know what the state is until after it's done because you never know, our job could fail. So we have Terraform plan, it ran okay. Let's go ahead and apply our Terraform job. So we run this Terraform apply at the command line. It's going to go out. It's going to give us some information. And we end up with this prompt, enter a value, yes. You have to explicitly tell Terraform that you want to do something. If it's going to affect, if it's going to change the state of anything in the target environment. So we type yes, we hit enter, and it goes out, and it goes through the process of creating the database. And so I want to show you what this looks like here in real life. This is my project here, and I can do Terraform plan. I'll go through that process, and we'll do Terraform apply. Again, it's given us all that information, and now it's going to start creating that database for me. So while it's doing that, we'll jump back here and kind of cheat a little bit and see what that looks like. A couple of things that I want to just kind of prompt you with are writing Terraform configurations and maybe adding a little style and maybe forethought. And there are some different schools of thought on how you can write Terraform configurations. The first school of thought is, hey, you know what? We can put everything in a single file. We call everything main.tf or my Terraform project.tf, whatever you might like. And we could put all of the variables, the outputs, the resources, the provider information. It could all go into one single file if you wanted. And some people like that. I'm more of a fan of having separate files for each resource. And the reason is that it just feels a little bit more portable to me to be able to do it that way. Because if I've got a really complex Terraform job that I'm going out and I'm working on, well, I might have some compute resources. I might have to create a VCN, and I might have to create storage, and I might have a whole bunch of different variables. But a lot of the work that I do could be really similar across multiple projects. Let's say that I'm building a lab for students to go in and practice working on a particular project. Well, my compute might be the same, so I could reuse those files, and I can certainly reuse my provider information for each of those different projects. And then the only thing that I have to worry about changing is maybe maybe my storage footprint changes a little bit, or maybe when I'm provisioning my compute resources, I might run a different script. And that is something you can do in Terraform. You can run scripts against infrastructure. You can do some really complex, really remarkable, deep configurations with Terraform if you choose to. So I like this idea of being able to have individual files that you can go out and just use them almost like Lego building blocks, plug and play. If you have a storage configuration or storage provisioner that already works for you, why reinvent the wheel and why make a really, really long single file with that storage information embedded in the middle and have to, like if you're troubleshooting, have to worry about, well, where is it in this file and where is it in that file? So that's kind of my preference. Again, though, there's no rule for indentation. There's no rules for spaces or tabs. It's really free form. You can have, just for example here, when I was creating this file here, you can have this variable DB name and define the type string on one line. You can put it on multiple lines. You could put type equals string, default equals 21C on one line. It really doesn't matter because Terraform will go through and it'll consume this and it will just digest it and parse it out automatically for its own purposes. And you don't need to really worry too much about how you're presenting it. You don't have to worry about order. So you don't have to have dependencies listed in order either in a file or in your directory. Terraform will go out and it will understand that if you are provisioning storage that's going to be attached to a compute instance, that the first thing it needs to do is create the storage so that then it can attach it to the compute instance. So let's take a real quick check here and look, and we can see, yeah, our database was created. And Aaron went through, it gave us a bunch of information. And this right here, this is changes to our outputs. This is what it was doing beforehand. Then it created this information. created our database, and it gave me little updates every 10 seconds to tell me what the status was. And a minute and 9 seconds later, I had an autonomous database created. And these are my outputs. You can see here my outputs. I got my DB name, and this time it gave me my database state as available, because it now knows the state of our database. If I were to rerun Terraform apply, it's going to come up and it's going to say, hey, you know what? There's nothing for me to do. All of the infrastructure that I had matches your configuration, so you are 100% good to go. When I'm all done with everything, if I want to make this go away, I have this Terraform destroy command. And just like Terraform apply, I have to give it this confirmation. Yes, I do want to destroy this. I understand that all of this is going to go away. Hit yes, and it will go out and it will remove all of the infrastructure that I built. So that is your quick introduction to Terraform. If you have any questions, please feel free to jump in and ask them now. I'm more than happy to answer them. If you think of something later on, you are more than welcome to reach out and contact me at through any of these channels. I love talking about Terraform, Docker, Oracle Diagnostic Tools, TFA, and the Gimmer and Cha and so on and so forth. More than happy to share or shoot the breeze about any of those subjects.
Thank you so much, Sean. I'm seeing that someone is writing in the chat window right here. In the meantime, I'm checking also Facebook and see if any questions over there. Thank you, Murali. Basically, Murali is saying, thank you, Sean. It was concise and well presented.
Thanks, Murali. Appreciate it.
Let me see. Nothing in Facebook. I'm checking if anything else comes through here. Shane also is saying thank you to you, Sean. And
my pleasure.
Oh, good. That means looks like there's no questions. Saying that, I would like to say thank you to you, Sean, as always. All your support you always have you give to the Oracle community, not only Asia Pac, but all around the world, for you in viscosity. And thank you so much for giving your time and sharing the knowledge. That's always important. Thank you so much.
It's been my pleasure. Thank you for having me, and thank you everyone for attending today. Have a great Wednesday.
Likewise. Thank you so much, everyone. Keep enjoying the conference. We still have another 4 sessions today and 6 tomorrow. And please take care and be safe. Thank you, everyone. Bye-bye.